A sequence is a schema object in a database that's not tied to any single table. It can be a way to generate a sequence of numbers across tables when you need unique values, perhaps so that the collection of all surrogate keys in all tables have unique values. You're not limited to generating numbers when inserting a row into a table. Instead, the next sequence number is generated when you call the next value for function, which you can assign to a variable or use as the default value for a column, just about anywhere and any way that you use an integer value. Unlike identity, a sequence isn't a characteristic of a table column, so a column that uses sequence values is not automatically protected from change as identity values are. Sequence numbers are not necessarily unique, particularly if the sequence cycles back and restarts. So if you need to enforce uniqueness for a column, then you'll need to put a uniqueness constraint on that column. Sequence values used during the course of a transaction are not rolled back if the transaction does not commit, which means that you could end up with gaps in the used sequence numbers. One nice feature of a sequence is that you can restart the sequence when you reach a certain number, such as to repeat the numbers 1 to 100 over and over and over again. You can also generate multiple sequence numbers all at once, such as to reserve 20 sequential numbers. So these are just a few of the ways that sequence numbers are enormously flexible. An important feature of sequences is that when you create the sequence object, you can elect to cache the values. You set this behavior using either the cache or no cache options on the create sequence statement. If you elect not to use caching, each time SQL Server generates a new sequence number, the change is immediately written to the system table on disk that keeps track of the latest used value. This can have a negative effect on performance, since it could dramatically increase disk I/O. But if you elect to cache sequence values, SQL Server writes to the system table only after a set number of sequence values are generated. The value that SQL Server writes each time is the next value to be used in the sequence. SQL Server keeps in memory only two numbers related to that sequence object: the current sequence value and how many values are left in a requested block of cached values before the disk write needs to happen. Every request for a new value in the sequence causes SQL Server to update these values in memory. Sequences are surprisingly useful in many situations. If you read Itzhak Ben-Gan a lot, you'll know just how useful sequences are. He's written a lot about various ways to generate them in older versions of SQL Server, requiring various kludges such as temporary tables. Now things are much simpler. The sample code shows some of the ways that you can use sequence numbers. Because a sequence object is a schema object within a database, the code is going to do all of its work within a sequences database. Okay, so I'll go ahead and create the database, change the database context, and then also create a schema to hold the objects called myStuff. All right, execute that code. We have a database, change the context, and have a schema. Now, the simplest way to create and use a sequence is to simply create one and accept all of the defaults. And that's what this statement does right here. This simple sequence object will generate big int values starting from the smallest possible big int, which is a very large negative number, to the largest possible big int, which is a very large positive number. So I'll execute that code, and now we have that sequence object. It's a persistent object within the sequences database. And then, in order to retrieve the next value for the sequence, you simply use the next value for function. And yes, it's a function, even though it doesn't look like one with the way they did the keywords there. All right, and then you need to specify the sequence object that you want to get the next value from, because you can have multiple sequence objects, as many as you want, within a single schema. Okay, so I'll go ahead and execute these 3 lines of code. And as you can see, I have a very large negative big int number. I have the next number incremented by 1, and then the next number incremented by 1 once again. Okay, so that's the simplest case. but you have a lot of options with how you create sequences. So you can control the behavior of different sequence objects. For example, you can set the starting value for a sequence. So this code does just that. It creates another sequence object called sequence from 1, and I'm saying that I want to start it from 1. Okay? So it's still going to be a big int, but it's going to bypass all of those negative numbers. So I'll execute that code. We now have a second sequence object within the database, and I'll look at the first 3 values there. As expected, I get 1, 2, and 3. It's always a good sign to see that SQL Server can actually count. All right, so now that you have a basic understanding of how sequence numbers work, take a look at this code and predict what the values are going to be. It's going to get the next value for mystuff.sequence1. We just executed the code there. You can see the most recent values. And then it executes next value 4 again and returns this within a select statement. Okay, you're clear what the numbers are going to be? Okay, so I'll go ahead and execute it. And we have 4 and 4. I'm kind of guessing you probably guessed 4 and 5, as I did the first time I played with code like this. Well, that's not right. This was kind of a trick question. SQL Server has a concept called all at once, so that all expressions that appear in the same logical phase, which is here the select clause, are conceptually evaluated at the same point in time. Since the statement refers to the same expression twice, the next value for mystuff.sequence_from1, it returns the same value in both occurrences. Now, this isn't something that's unique to sequence numbers, but because of how you use them will probably cause confusing results. So be careful. Okay. So here's another option of a sequence number, or of a sequence object. So I'm creating a descending sequence. Here I'm going to start with 0, and I'm going to increment by 1. So you can specify what the increment value is. So I'll execute that code, and now we have yet another sequence object within the database. And now I'm going to use that sequence in a little bit different way. This select statement reads rows from the sys.databases catalog view, which lists all the databases installed in this instance of SQL Server, both system and user databases. The result set requests a new sequence number right here for each row that's returned. So this isn't the same as the previous confusing example showing the all-at-once concept. So this is actually a new sequence number requested for each row in the result set. All right, so when I execute this code, there you can see the results. So I'm getting all of the tables that are currently installed, again in this instance of SQL Server, and it's using that descending sequence that I created that starts at 0 and counts downward. And you can see all of the tables here, along with the sequence number. Okay, then here's another example that does some things in fairly silly ways, but it shows just how flexible you can be with sequences. So the code defines a sequence options sequence that starts with 27, increments by 3, the minimum value is 22, and the maximum value is 37. Most importantly, I'm setting it to cycle. So when it exhausts all of the sequence numbers counting up by 3 within the range of 22 to 37, but initially starting with 27, then it's going to recycle and just restart using the numbers again, starting each time with 27. Okay, so I'll create that sequence object. And here's some code that exercises that. So I'm going to declare I int equals 0, and I'm going to execute this loop 15 times. And it's going to select the next value for that sequence object, the one that I just created, as the sequence value, and then it's going to count up. All right, so go ahead and execute that. And I'll expand this a bit so you can see all or most of the results. So as you can see, it started at 27, counted up by 3, counted up by 3 again, counted up by 3 again, counted up by 3 again, but saw that it was going to exceed the maximum value, and so it restarted at 22. So that's the minimum value. It doesn't restart at 27, it's just when create the sequence object, that's the value it starts with. So 22 is the next one. It continues to count up 25, 28, 31, 34, and 37. So kind of an interesting thing here is that the first time through the sequences, it didn't hit the maximum value because incrementing by 3 bypasses it. But this time, it hit that value. And then it continues on down through the cycle once again. So as you can probably imagine, you can get pretty creative with how you define sequences. Okay, so I've shown you some examples of how you can use sequence objects. But most typically, you're probably going to use sequences with a table. It's really targeted at generating column values in a table, particularly to replace identity values. For example, consider a simple dogs table. It has a dog ID, name, and age. Dog ID is defined as an int, and it's the primary key. But notice that I'm not defining it as an identity value. But because of the way I'm defining it here, it's automatically indexed, and SQL Server enforces the uniqueness of all its values. But because it's not an identity value, SQL Server isn't going to automatically generate values for dog ID when I insert new rows into the table. Remember, sequences are not a characteristic of a table. Okay, so I'll go ahead and create that table. I can get that selected. Okay. And then I have this code here. So one of the options that you have with a sequence is to restart the values using the Restart With option. And so what this code does is it restarts sequence from 1 to restart at 1, no matter how many sequence numbers you've already used up. Okay, so I'll go ahead and execute that alter sequence statement. Okay. And then I'm going to insert some rows into the table. So I'm going to insert Marty, Bonsai, and Jewel. And notice that to generate the dog ID value, I'm using the next value for function for that sequence from 1, and using that for each of those different rows. All right, so we've inserted 3 rows. And we can take a look and notice that we generated 1, 2, and 3, as expected. Now, maybe a little bit more useful would be to set the default value of a column to use sequence numbers, either when you originally create the table or by altering an existing table. So here's some code that alters the dogs table, and it adds a default next value for sequence number for dog ID. So now, if I don't specify a value in an insert statement for dog ID, then it'll go ahead and grab the next sequence number using this particular sequence object. So I'll go ahead and execute that. And I'll add a few more dogs. Notice this time I'm only providing name and age because I have a default value set for dog ID now. And I'll execute this code. Take a look at the values in the table, the rows in the table, and you can see that 4, 5, and 6 were automatically generated because I used that same sequence object. All right, I have one more example here to show you, and this is something that I adapted from books online for using a sequence number in multiple tables. So what I'm going to do here is I'm going to create an event counter. A little typo there, fix that. So I'm going to create a sequence called event counter as an int this time. So I'm creating it as an int as opposed to the default big int. I'm going to start with 1 and increment by 1. Okay, so nothing new here other than defining it as an integer. And I'll execute that. And we're still within the sequences database. All right, now I'm going to create several tables. The idea here is that I want to create tables that record different kinds of events. So I have one for process events, one for error events, one for start and stop events. And they're all defined pretty much the same. I have an event ID, primary key clustered. The default value is the next value from the event counter. And then I have a date time with a current date, event code that I'm going to insert, and then a description about the event, whatever that kind of event was. All right, so I have 3 different tables that essentially partition the different kinds of events. So I'll go ahead and create all 3 of those tables all at once. And there we have the tables in the database. Okay, now I'm going to insert some rows into those tables. So I'm going to insert into start-stop events, something about equipment and start or stop, and just putting in basically random values. And some information here to process events about what the process was, process event here, error events, something about a feeder jam, and so forth. So I'm just putting rows in the various tables. What's important here, though, is that each of these has that event ID, and I'm not providing a value for that event ID, or in fact for the event time, because that's not just automatically going to use the get date, the current date and time value. Okay? All right, I'll go ahead and insert those rows. And then I'm going to read the data back. And I'm going to use common fields. And this is going to show that the sequence has been used across tables. So I'm going to select event ID, event time, description from process events. I'm going to union it with the data from error events and union it with event time. And I'm going to convert the value within start-stop events to be either start or stop so that it's not just numeric values. And I'm going to order by event ID. And I'll execute that. And as you can see, even though these are values, these are event IDs in different tables generated by inserting rows at various times, I get a sequence of numbers starting with 1 and with no gaps. I didn't do any transactions or anything else that might cause a gap in the sequences or delete rows or anything like that. So I got the values from 1 to 7 with all of the data. So this shows one of the more powerful ways that you can use sequences if you need unique keys across all of a set of tables. An interesting aspect of using the sequence object is that if you request a sequence number when a transaction is active and the transaction is rolled back, the next sequence number is not rolled back. Okay, I talked a little bit about this. And this is some code that demonstrates that. So I'm going to select the next value for sequence from 1, the sequence object that I created previously. I'm going to do the same thing within a transaction that I'm going to roll back. So I'm going to get that value. I'm going to see the result set. And then I'm going to select the next one from the sequence object as well. All right, execute that code. And as you can see, I get 7, 8, and 9. If this sequence value had been rolled back, I would have gotten 8 for this one. This would have been rolled back. I would have gotten 8 instead of 9. But 8 is not rolled back because sequence numbers are generated outside the scope of a transaction. Okay, so you need to be aware of that behavior. And then as usual, there's various features within SQL Server that let you access and manage sequences. And you can do that both with catalog views as well as graphical tools in Management Studio. All right, so for example, you can use this query right here to view the previous values of all available sequences that are defined in the database. I'll execute that, and you see all of the sequence objects that I created. And the current value, it's a little bit misnamed because it actually returns the last generated sequence value, not the next value. So for example, event counter, the last number used was 7. You saw that in the previous code that I executed. Okay, so current value is the last value that was generated and requested. Okay, that catalog view has a lot more information. So if I do a select star on it to retrieve all of the fields, you can see that it has object ID, as do most things within SQL Server. And then, let's see, it's a sequence object, creation date, modified date, and so forth, a few other things. There you can see the minimum value and the maximum value. These are the defaults because I didn't specify those, but these are different options that I set for sequence numbers. This is an integer instead of a big int, so it has a smaller range. Also indicates whether it's cycling, whether or not it's cached. I didn't really do anything with that. And then here's that current value, which again is the last value that was requested. And then you can also view information about the sequence objects here in Object Explorer. If I go down into the, I have to refresh that databases. There's the sequences. I'll drill down here into programmability and sequences, and there lists all of the sequence objects that I created. And if I double click on one, it opens up a dialog box that I can use in order to change most of its characteristics. And there I can change the minimum value, maximum value, set caching options, set permissions on them, and extended properties.